2018 Connected Particles Q4a. A block A of mass m is connected by a light inextensible string to a second block B of mass 3 kilos. They slide down a rough inclined plane which makes an angle alpha with the horizontal, where tan alpha is 3/4. We'll work out sine and cos alpha now in a minute. The string remains taut in subsequent motion. The coefficient of friction between A and the plane is 3/4, so along here. And the coefficient of friction with B in the plane is 1/3, so a bit of restriction here. The system is released from rest. Find the acceleration of B in terms of m and the value of m if the tension in the string is 3.92. Okay, let's deal with m first. Create your diagram. Got our alpha. So going down, we have mg straight down. We have a force coming down this way, and opposing force here, which we'll call R. Well, we're going to have two R's, so we'll call this one R1. So going down this way, I have my alpha in here. So this is adjacent to alpha, so mg cos alpha. And going down this way, we have mg sine alpha. And going back this way, we have friction restricting the movement down, and it's going down the hill, so my acceleration is in this direction, A. I also have this string here, so there's a tension in this string here. Okay, let's start with my R. I think the only forces going in this direction, up and down out of the block, are my R1 and my mg cos alpha. So we can say that R1 is equal to mg cos alpha. Let's just do a little triangle here for alpha O/A. So we know this is our 3, 4, 5 triangle. So the cos of alpha, 4/5. So R1 is equal to 4mg/5. We also have this F is equal to mu R, where mu is the coefficient of friction, or mu R1 in this case. Well, we call this one F1. We're going to have two different ones, F1. So my F becomes, or my F1 becomes, jump up, what was A? Block A was 3/4. So 3/4 times 4mg/5. And that's going to give, well, the force cancel, and we're left with F1 being 3mg/5. We also have my forces at play here. What have we got with? We're going in this direction, same as the acceleration. So we have a T and we have an mg sine alpha. So they're the two forces going down. So we're going to have T plus mg. Well, let's get sine alpha. We sine alpha is going to be O/H, 3/5. So T plus 3mg/5. This one here. And then take away what's opposing that, which is my F1, which we're just after working out to be 3mg/5. Well, these are going to cancel, 3mg/5. And that's going to be equal to ma. So this is my force equals mass times acceleration equation. So the mass is just m, and the acceleration is a. So simply, this is just T is equal to ma. So that's for block A. We can try and fit block B in over here. Three alpha. So we have my alpha, my 3g, making this one 3g adjacent to alpha, cos alpha, and this direction 3g opposite alpha, sine alpha. We also have my F, we're going to have to call this one F2, and I have my R, which we'll call R2. So I can start by getting R2. R2 is equal to 3g cos alpha, and we said cos alpha was 4 over 5, so 3g by 4 over 5. So we're looking at R2 being 12g over 5. If we work with F2 is equal to mu R2. So what was mu for this guy? 1/3. So F2 is equal to 1/3 of R2, 1/3 of 12g over 5. So we're going to get 4g over 5 here. F2 is 4g over 5. And the forces at play, well, we should probably write our acceleration here. Our acceleration in this direction. So what's going in this direction? Well, I've no string going on this side of the block here. So the string, I should put back this way. That's my t. So we're starting with 3g sine alpha. 3g, now what was sine alpha was 3 over 5. 3g sine alpha, that's this one. 3g sine alpha, and then take away these two forces that are opposing it, t minus f2, which we've got to be 4g over 5. That's equal to m, which is 3 times a. So simplifying this down, we're going to get 9g over 5 minus 4g over 5 minus t is equal to 3a. So 5g over 5, well, they cancel, so we're just going to get g minus t is equal to 3a. We're asked to get acceleration in terms of m. No, we're asking part 1 acceleration of b in terms of m. And we've worked out t to be ma. So we can sub that in over here. So g minus ma is equal to 3a. So factor out my a's. G is equal to 3a plus ma. G is equal to a times 3 plus m. So that would mean that the acceleration would have to be g divided by 3 plus m. Second part asks us to find the value of m if the tension in the string is 3.92 newtons. So here's my tension in the string, T equals ma, and we've got a value for a there over here. It's g over 3 plus m. So T is equal to m multiplied by, do a bracket, g over 3 plus m. So we're told T is 3.92. 3.92 is equal to mg over 3 plus m. So we need to find the value for m. So we need to simplify down to get m on its own. So if I cross multiply here, I get 3 by 3.92. That's going to be 11.76 plus 3.92m is equal to mg, so 9.8m. So 11.76 is equal to 9.8 minus 3.92, which gives me 5.88m, and this works out evenly, it's double that. So m is going to be equal to 11.76 divided by 5.88, so the mass will be 2 kilograms.